Hello everyone. In this video we're going to solve a couple trig equations building on work from prior lessons. And we're going to look at a couple examples where we're going to be solving the trig equation and we're going to get decimal answers. We're going to have to use a calculator for that. All right, so let's look at number 26 in this list here. All right, so the equation sine of x equals 0.48. All right, now we're going to be able to get one of the answers with the inverse trig function, inverse sine, but not all of them. All right, we want all solutions in the interval from 0 to 2 pi. All right, so for this example, we want to note is, remember, for every point on the unit circle, the x-coordinate is cosine of that angle, the y-component is sine of that angle. All right, so and sine is the y-component. So we want to go to about 0.48. So let's go on the y-axis to roughly 0.48. All right, and there's 2 points where the unit circle, there's 2 angles whose terminal side intersects the unit circle at height 0.48. One of them's over in quadrant 1. All right, so we can draw that angle, and that's the one we're going to get with the inverse sine function. All right, so that's the angle x we're going to be after here. So let's just write that down. All right, if we know that if we have sine of x is equal 0.48, well, if we want to solve for x using the inverse trig function, then what we're going to do here is take the inverse sine of each side. So we're going to do inverse sine on the left, and then inverse sine on the right. And that's going to give us one of our solutions. All right, so on the right we have the 0.48. On the left we have inside there the sine of x, and these things undo each other as inverse functions, so we get x is going to equal then the inverse sine of 0.48. All right, I'm going to round to 3 decimal places for the purposes of this video. And if we're asked to do something different, we would do that. All right, that's going to be one of our answers. That's the angle that's drawn there. All right, so let's compute that. And then to get the other one, we're going to need to use some symmetry. All right, and what we know from the definition of the sine and cosine. All right, so if we compute this with a calculator, we're going to get that x is approximately equal to 0.500. I'm going to actually round this off to like 5 decimal places. It's 500. Write that. 65. If I go to 5 decimal places. The reason I want to go out a little bit further because that's very close to 1/2, 0.48. We know sine of 30 degrees is equal to 1/2. So the inverse sine of 1/2 would be exactly 30 degrees. All right, now we're going to be a little careful here. This is in radians here. All right, so this is in radians. So we're not talking about degrees. This is 0.50065 radians in this case. Remember, the inverse trig functions return angles to us. All right, so there's one of our answers. Again, I'm just writing the word radians out here for emphasis. We don't need to do that for the problem. So that's one of the solutions on the interval from 0 to 2 pi. That's one angle whose sine is 0.48. All right, again, rewriting that, that's close to, all right, this has got to be close to, but a little bit less than 30 degrees if we were going to get that in degrees. All right. In fact, why don't I just compute that in degree mode as well? All right, and if we did that in degrees, we would see this is 28.685 degrees. All right, but again, we're not told to get that in degrees. When it says find all the solutions in the interval from 0 to 2 pi, we're assuming we're talking about finding solutions in radians there. All right, now what about the other solution? There's one more. We know that there's another angle that intersects the unit circle at height positive 0.48, and that angle lives over in quadrant 2. All right, now how do we find that one? Well, what we can recognize is that the angle we just found and this angle here, this reference angle that we've drawn there, are the same. Okay, now hopefully I've drawn that decently enough. All right, those angles are the same. So what we really want to do is to determine the angle we're looking for, which is going from the positive x-axis over to its terminal side. That angle drawn in red there, the other solution will be 180 degrees or pi radians minus the solution we just found, which is inverse sine of 0.48. Now, for accuracy's sake, we're better off plugging that into the calculator as written, and just let the calculator take care of that. So computing that, With the calculator, what are we finding? We're getting that this is approximately equal to 2.641. Again, that's radians. So that's enough for this problem. We found the two solutions. All right, one of them being 0.50065 radians, the other one being 2.641 radians, and that's the two solutions of this equation in the interval from 0 to 2 pi. If we wanted to write the general solution out, we certainly could do that. All right, and I'm just going to do that just to emphasize it. Well, if we were going to write this general solution out, what would it look like? Any solution to that equation would have to be an angle which would be coterminal to one of the two drawn. So the general solution would look something like this for that problem. And we weren't asked for it, but just doing it for emphasis. The general solution would be that x would be 0.5065 plus any multiple of 2 pi. All right, adding or subtracting any multiple of 2 pi. And the other part of the general solution would be, again, we're rounding this to 3 decimal places or more, 2.641 plus any multiple of 2 pi. All right, the only way you're going to be a solution is if you're going to be coterminal to the angle, to one of the angles that we wrote down, and therefore that's the general solution. All right, let's do another example, all right, where we're working with the decimals here. I think the other one we want to do is, I'm going to look at cosine, number 29, which is cosine of x is negative 0.55. All right, so let's take a look at that. All right, so I'm just going to put in the unit circle, picture the unit circle here, make this a little bit smaller. All right, so again, what are we looking for? Cosine is the x component, so we want to know what angles have an x component of negative 0.55. So let's put that on the x-axis. There's two angles whose terminal side intersects the unit circle at an x value of negative 0.55. One of them is in quadrant 2. The other one is in quadrant 3. All right, the inverse trig function, inverse cosine, is going to find us the one in quadrant 2. We'll have to use some symmetry to find the other angle, which is in quadrant 3. All right, so speeding this up a little bit from the last time, taking the inverse cosine of both sides, we would then get x would be inverse cosine of negative 0.55, and then we'll compute that. And that comes out to approximately 2.153. I'll just round it to 3 decimal places. That's radians. Again, our job is to find the first two solutions. All right, so 2.15, again, that's between pi over 2 and pi. Pi is 3.14. That'd be half revolution. Pi over 2 would be half of that, which comes out between 1 and 2. It's 1.57 approximately. All right, so that's one of our answers. We've just found, I'm going to just color that in here. That's the angle we just computed right here. All right, now how do we compute the other value? Well, all right, for that one, we've got to take a little bit more care than the previous one. We want to know this angle that I'm going to draw in red here. The positive angle will be starting at the positive x-axis and going counterclockwise till we get to that terminal side. The most efficient way to find that angle is to notice that the angle we just found is the same as this one that I just drew in green there. So if I want to come up with a red angle, what we're going to do is take this angle red, which is our other solution, which we'll call x. We're going to take a whole revolution, which would be 2 pi radians. Okay, just going to draw that in and then erase it there. I'm going to draw that in black. A whole revolution would go all the way around, and then we're going to back up or subtract the angle we just found using the inverse trig function. So the angle we're looking for then is going to be 2 pi minus inverse cosine of negative 0.55. All right, now again, don't round using the previous result here. Let's let our calculator handle that work. So computing that, we get, I'm just doing this with a handheld calculator, this is approximately 4.13 0. All right, again, those are our two solutions in radians. All right, so notice this one's a little bit different here. All right, we're using that angle we just found, but we're subtracting that off from 2 pi to find the other angle in quadrant 3. It's very similar. We could write the general solution out if we needed to. Any solution of this equation, cosine of x equals negative 0.55, would be an angle coterminal to one of these two, so you'd add or subtract a multiple of 2 pi to these two solutions to find any other solution. Okay, so let's do one more example in this video. All right, and these types of problems are similar to the ones that we've just worked out. All right, let's take a look at one more together, and let's do what's listed as number 39 here. All right, so this is going to be similar to what we've been working through. All right, we're going to have a small difference here. All right, we're supposed to find the first two positive solutions, and notice that one other difference is we don't just have x inside of our argument there. We've got pi over 3 times x. All right, so the first thing we want to do is divide both sides by 5. We want to isolate the trig function. So we get cosine of pi over 3, x is going to equal 1/5. All right, then we're going to make a substitution. Since we don't just have x on the inside, we want to kind of blur our eyes to that for a minute and call that u, or something else if you want to. So, pardon me, jumped on me a little bit there. All right, so we want to say, okay, this is really like cosine of some angle. We're calling it u is got to equal 1/5. All right, for that, all right, what we've seen before is we're going to have, all right, two solutions to that general equation, and to this one, it's going to be in quadrant 1 or quadrant 2. We're going to have to then undo our substitution to find the actual angles x. All right, just paused and brought in the unit circle here. So what we've seen from our previous work, from cosine is 1/5. 1/5 is about 0.2. There's going to be two angles. One of them is going to be in quadrant 1, roughly speaking there. And again, this is 1/5 or 0.2. All right, the other one's going to be down in the fourth quadrant. The other angle whose x coordinate is at 0.2. My picture's not perfect, but good enough, is going to be this angle drawn with terminal side down here in quadrant 4. All right, so, and those are our two angles in the interval from 0 to 2 pi that are going to make this work. All right, now to find that, we're going to use the inverse trig function. All right, so we're going to have inverse cosine of 1/5 is going to be one of our solutions. All right, the other solution, the one that we have in green there, and we'll get that with a calculator in a minute, will be, like we did in the last example, we're going to do 2 pi minus that angle we just found to find the positive angle, which is going to go from the positive x-axis counterclockwise to that terminal side. So it's going to be 2 pi minus inverse cosine of 1/5. All right, now computing those, what do we see? We get, in this case, these two angles. We get approximately here 1.369. All right, I'm going to go 4. And then the angle written in green here is approximately 4.9137 radians. All right, now to find the first two positive solutions, what we actually want to do is write down the general solution by undoing this substitution. And we're going to do that, so we're going to replace u now by pi over 3x. So really what we have here is pi over 3x would equal inverse cosine of 1/5 or 0.2. And then separately, we'd have pi over 3x would equal 2 pi minus inverse cosine of 1/5. Now what we're going to do here is solve each of these equations, all right, and really any other solution would be a full rotation, positive or negative, so it would be an angle coterminal to that. So we have to add on the 2 pi k, where k is any positive or negative integer, and then we'd have to solve for x by dividing both sides by pi over 3. So we really have inverse cosine of 1/5 plus 2 pi k divided by pi over 3. And the other one would be 2 pi minus inverse cosine of 1/5 plus or minus any multiple of 2 pi, and then that would be divided by pi over 3. Now, the way to finish this problem off is then to plug in values for k to find the first two positive solutions. All right, so I've done that in Desmos, and I'm just going to copy and paste the results here. Again, you plug in k equals 0, which would just be these two solutions right here. All right, but again, we got to be a little careful here, because what I had for u was before we divided by pi over 3. All right, so we got to be a little bit careful when we go to actually solve. We want to write the general solution out, and then after we do that, plug in values for k. Plug in 0, 1, 2 to find however many solutions we need. So let's just take a look at it. That's the result what you would get in Desmos. Notice I wrote arc cosine in there. The first two positive solutions are given here by plugging in k equals 0. All right, the next two positive solutions we would get by putting in k equals 1, which I'm just going to throw in here for emphasis. But notice we were supposed to find the first two positive solutions, so those are the values we would get. And these are the values for, in this case, x. Notice that's different than what we found for u. These would be the next two positive solutions. Those are different than what we found for u, because here we had to find those results, then divide by pi over 3 after. Right? All right, so again, the best way to do this is to write the general solution out. All right, and then plug in your values for k as needed to find as many solutions as indicated in the problem. Hope you found this useful.